Hello, welcome to demola. And today's lesson we're going to be talking about ionization energies and the periodic table. We're coming out of module 2, moving into module 3, where we're going to be learning about trends, reactivity, the whole lot. We're going to be masters of the periodic table after this. Let's get into it. Okay, so the first we need to talk about is the structure of the periodic table. And we should know from GCSE that we order in number of increasing atomic number. Yeah, so increasing atomic number or increasing number of protons in that nucleus. Yeah. That is how we arrange a periodic table. So hydrogen has 1 proton in the nucleus, helium has 2, carbon has 6, and we keep just going on from there. Yeah. What you should also know is that we're arranging the periodic table in groups and periods. So a group is a vertical column here, so that's group 1, and a period is going to be a horizontal row. So for example, this is going to be period 2 in orange. Yeah. And that's how we order the periodic table. You should see trends going across a period, and all of the elements in the same group should have similar chemical properties. So in a period, we know that they have the same number of electron shells. Period 2 has 2 electron shells. In group 1, all of them have 1 electron in the outer shell. And that is kind of how we do our periodic table. We did another video on electron structure. That's the start of the video, electron structure. This will go through SPD block and how to do an electron configuration, which is all very, very important as well. So I feel like that was good to mention, but what we really, really, really want to talk about is the ionization energy. And please, I promise you, this definition does come up and is a very easy question to get 2 marks on. Yeah. You define your ionization energy as the energy required to remove 1 mole of electrons from 1 mole of gaseous, very important, gaseous, we'll even highlight it, gaseous atoms to form 1 mole of 1 plus ions. Yeah, very important that you're mentioning that it's gaseous. Yeah, and this is just the first one. So if it is second ionization energy, you'd say 1 mole of electrons from 1 mole of 1 plus ions to form 1 mole of 2 plus ions. Yeah. And if we draw equations, also very important to be able to do the equation. Literally, we have enthalpy change, and as a first ionization energy. That's what this means. Yeah. And we're doing it for sodium. So we have sodium gas going to sodium ion plus electron. And you need to remember this electron is very important because without it, our equation is not balanced. Yeah. So we need to balance the charges, which is why we add on the electron there. Now, when we're talking about ionization energies, questions that come up a lot on exams are about the trends, yeah? So your ionization energies differ along a period and they also differ down a group, yeah? So if we look along a period, what we can see here, we've got element, it's in group 2, it's got, as in on period 2, because it's got 2 outer shells, or it's got 2 electron shells, yeah? And you can see it's in the same period, but they have different number of electrons in the outer shell, so they're in different groups, yeah? When we move a longer period, there's going to be more protons in that nucleus, yeah? So that nucleus is going to have a greater positive charge. Cool? Because they have the same number of shells, there's a phenomenon called shielding, right? And this shielding is kind of like how that nuclear charge kind of passes through the electron shells to attract the outer shell of electrons, yeah? So we're going to say this shielding is similar because there's the same number of shells. So there's kind of the same barriers that the nuclear attraction needs to go through in order to get to the outermost electron. Yeah. If we've got a greater nuclear charge, so there's more traction on the outer shell, and the shielding is similar, then that means that our atomic radius is going to go down. Our atomic radius is going to go down, meaning that the outermost electrons are now closer to the nucleus. Yeah. And that means that nuclear attraction on that outermost electron is going to be stronger. So we are going to need more energy to overcome that stronger force of attraction between the nucleus and the outermost electron. Hence, along a period, ionization energy is going to increase. Now we talk about a group. I've got 2 elements in group 3. One has 2 electron shells, one has 3. Yeah, we're kind of run through the same logic. Yeah, we're going to increase the atomic radius. Why? There's more shells, right? So your atomic radius is definitely going to increase. And if we have an increased number of shells, that means that there's more barriers, there's more opposition to the nuclear attraction to get to the outermost electron. Yeah, it has to go through more layers, so your shielding is going to increase. Yeah, if we've got increased atomic radius, increased shielding, that means that the outermost electrons are further from the nucleus, so the nuclear attraction on that outermost electron is weaker. So we don't need as much energy to then remove the outermost electron because that nuclear attraction was weaker. I hope that makes sense. It's a lot of key terminology, so if you have to listen back. But that's how you're going to describe the trends along a period and down a group. And definitely, I can't emphasize enough to use words like nuclear charge, shielding, atomic radius. These are the kind of things that you will see in a mark scheme, yeah? So it's very important that you use the terminology that the examiner wants to hear. As always in life, we have exceptions to the rule. So I told you along a period, the ionization energy is always going to increase, right? And we've got period 3 here. But you can see there's a dip here, and there's also a dip here, yeah? We need to explain that, right? So we have unexpected dips at group 3 and group 6, which is aluminium and sulfur in this case. But it's also going to happen in along period 2 as well, that you're going to have these dips. And we kind of need to know why. So if we look at the first one, magnesium and aluminium, yeah, I can see magnesium, after we just focus on the outer shell, yeah, 3s2, aluminium is 3s2, 3p1. Now there's this thing that we call full stability, yeah? This has a full, let's highlight it, this has a full s orbital, yeah? That's what the outermost electron is. That's where we're going to remove the electron from this fully filled s orbital. And that has stability. That's very stable because it's full, yeah? Compared to aluminium, where were we going to take that first electron from? We're going to take it from 3p1, from 3p, yeah? This 3p is not full, yeah? This is going to require less energy to remove compared to disrupting the stability that the 3s orbital has when it's completely filled, yeah? So again, I'm just going to say 3s fully filled has a lot of stability. 3p with just one electron is not as stable as that. So we're going to find it easier to take out the electron, which is why your ionization energy dips down. And we've got kind of similar thing happening here with phosphorus and sulfur, right? So if we're taking out this electron, right, we can say that this is half full, yeah? This 3p orbital is half full compared to this 3p orbital in sulfur, which isn't half full, yeah? We have a concept half full stability as well. So this has a half full stability, whereas this one has this one electron just sitting there. That's the one that we would have removed, right? So we require more energy to disrupt this half full stability compared to just removing an electron from 3p with 4 electrons, yeah? So it's just about disrupting stability, yeah? With the first one, group 2 to group 3, we're disrupting the full stability of the s orbital. When it's from group 5 to group 6, we are disrupting the half full stability of the p subshell. Hope that makes sense. Okay, and we now need to talk about successive ionization energies. So, for example, we have magnesium right here, and I'm just showing this diagram here. We're gonna do the first, the second, the third, the fourth, the fifth, the sixth, all the way to the 12th ionization energy. We can do that. Yeah, we're just removing all those electrons. Now, whenever you are talking about successive ionization energies, I need you to look at the number of shells and the number of electrons in each shell. So if I look at magnesium, I know magnesium is in group 2. It's got 2 electrons in its outermost shell. Yeah. So in the third shell here, it's got 2 electrons. I've done those. Now, we talked about how ionization energy changes is across a group. When we have less shells, it means that we're closer to the nucleus, so there's more energy required to remove them. Whereas if we're in the same shell, you could imagine it's going to be roughly similar, right? So we're going to see that there's a massive jump. You'll normally see a big jump when you're going between groups, yeah? And then, or when you're going through shells, because this is now the second shell. And you can see again, we've got a massive jump here when we're going to the third shell, yeah? I hope that makes sense. So I'm using the information I have. How many shells? Sorry, the first shell. So I'm using the information that I have. I'm thinking, okay, it's got 3 shells, so I'm expecting to see at least 2 big jumps. Yeah. How many electrons in each shell? The first one has 2, the second has 8, the last has 2. Yeah. You've got to consider those type of things when you're drawing graphs because they can ask you to draw graphs about this. Yeah. And they can also ask you to interpret. So just think about such things. Okay, so I've tried to be as succinct as possible, but it's time to do some questions. So we've got our first question here. Remember to pause if you need to. But here we want an equation. We want to explain why first ionization energy of strontium is less than calcium. Yeah, make sure you're using a periodic table. And then the second question that we've got here, we have equation for the third ionization energy of aluminium, and then to draw this graph. So I hope you can see both questions. Again, make sure you can pause the video. I hope I've left enough time to see both. But yeah, have a go at those questions. Okay, now it's time for the answers. So, as you can see, if you're drawing out the ionization energy of strontium, we need to do the same principles, yeah? So this is the second ionization. So we're starting with a 1 plus ion. And remember, it's all gaseous. And we went to the 2 plus, but if you can imagine, the charge here is plus 1. The charge here has to also be plus 1. So we add on our E minus there. Cool. Now again, this is the same kind of thing we were talking about when you have to explain yourself. Yeah, they have very key terminology they want you to say. So, like I said, they always want you to say about atomic radius. They want you to talk about nuclear charge and shielding and nuclear attraction. Yeah, so make sure you're referencing all of those things, and then it will just be the same that we talked about earlier. Yeah, strontium is lower in the group than calcium, so there's more shells. So that means that there's more shielding, so there's less nuclear attractions. Yeah. Then again, third ionization energy of aluminium, same thing. We start with Al2 plus, all in the gaseous state, and then we need the charges to balance. So if it's 2 plus here, it has to be 2 plus here, so we need E minus. And then when you're answering this one, I've actually drawn the graph that you should kind of expect to see here. So you should expect to see 2 jumps because we're going from the third, second, first shell. Yeah, so third, second, and first shell. And then you should know that there's going to be 3 in the third shell, 8 in the second, and 2 in the first. Hope that all makes sense. Okay, and it's time to wrap it up. So we're going to end with our A-star tips. Just be confident on the arrangement of the periodic table. It's not typically a question that you would expect to get. I know there's one past paper that you might end up seeing. There's a lot of questions about the periodic table, but I think it's relatively easy marks compared to everything else you're expected to learn. So just be very confident with it. Know the definitions for ionization energies. I think this becomes so much more apparent when you get to topic 5, but these definitions, especially for enthalpy changes, are such easy marks. Yeah, so don't miss out on those. Equations, again, another bit that's kind of really easy marks. Yeah, if you know what's going on, you can write an equation for it. Know the exceptions, right? So we said about group 3 and group 6 is where you have exceptions. Know those, be able to explain it, because those are what the examiner really likes to ask. And then when you're talking about explaining trends, another question that examiners really like to ask. So know about trends in ionization energy along a group and across a period. Yep. Next thing, what you don't do, confuse it for reactivity. I think because the explanations are relatively similar, and we'll get through it in the next video, but because they're relatively similar, some people think about ionization energy as like the reactivity, and it just isn't. So don't confuse those two concepts. And also, that thing that we had about the exceptions, I feel like it's almost too big brain to try and draw that in a graph if you're just taught to do successive ionization energies. Of course, if the question maybe like hints towards it, then think about doing it. But typically, they just kind of want to see the points going up and then a big gap if you're going across a period. So don't try to overthink it. Yeah. And that should be a wrap on this video. So I hope it's been really helpful. Any questions at all, get into the comments below and ask. We are now in module 3 about periodicity. So a lot of this is going to be trends, identifying things, and maybe a lot of calculations. Yeah. Please drop a like on the video if it helps. Subscribe to the channel as well if you're new. We've got the Instagram and the TikTok, both at demola. I really, really hope that this has helped you, and I'll catch you in the next one. Bye for now.